Thank you very much, Mark. We're just one, hopefully, exciting presentation away from lunch. And thanks for coming and joining me at this presentation. As Mark mentioned, I'm Benjamin from Conterra. I'm a geographer, certified trainer in FME. And I'm working as technical sales at Conterra in Münster. My principal work fields when it comes to sales and FME are FME Cloud, and MapApps ETL, which is an extension for our product MapApps that is based on ArcGIS Online, and Inspire Solution Pack for FME. Those who are from Europe may know Inspire. There's Inspire regulation about harmonization of data across Europe. So, but what I want to start with is a quick overview of the European Open Data Portal. So what's the main purpose? We harvest open data from public administrations across Europe. That's the main task of the European Data Portal. And so these are some screenshots just from the website. You can go there and have a look yourself if you want. They're providing data organized in 13 different categories, such as health, such as economy or public administration. There's a calendar of open data events across Europe. There's a dashboard with fully information about all the data sets with data fact sheets to get a quick overview about all the data that is provided. And there are use cases shared with the users so that you have an idea how you may use the data. They're given access to a large amount of data, so you see how many data sets can be found there. And there's some metadata quality dashboard when it comes to checking the accessibility of the data. They're checking the compliance to the DCAP AP specification, which is a specification used in Europe for metadata. Yeah, and you can have a preview of some of the data. So this is where Conterra came in with the MapApps. So you can just visualize the data instantly in MapApps. It's a streaming into GeoJSON and WMS, which can be displayed, for example, here in these are biotopes of the North Sea in Germany. And you can just have a quick look at the data before you download it or integrate it in your data portal, your own. So what's the problem in this project? How to find all the data and how to make it accessible and findable within the European Data Portal. So what we had to do was harvest the existing catalogs, maybe, for example, Inspire. As I said, every European country is mandated to provide data to the European Commission on all administrative levels of Europe. And so we thought we can use those Inspire data to integrate into the European Data Portal. We have to map it to a common metadata specification, the mentioned DCAT AP specification. And we had to build an adapter architecture with a RESTful API to be able to provide those metadata to a search index engine and to make it findable for all the users of the European Data Portal. So what we built was a gazetteer to enable a spatial search. That means that we wanted to link the data, all data sets provided with a spatial index, with a spatial context. Our first thought was that there's an annex theme. All the Inspire regulations are divided into 34 annex themes, and one of them is geographical names that already contains a lot of places and names and point geometries. But the problem is that not all countries are already providing Inspire Annex 1 geographical names data sets. So we had to add as well geonames.org data for axonoms. That is to say, For example, the city of Cologne is named Cologne in English, but in German it's Köln, or I don't know, in Spanish it's Colonia, Francisco? Yeah, it's Colonia. So to make the data findable with different place names, we added geonames.org data for the exonyms. And we added member states bulk data, for example, shapefiles, to just extend the information. And of course, we used continuous automated updates processes with FME to feed the Smart Finder search index. Smart Finder is another product of Conterra for metadata search, and that was also included in this project. So what we did individual workspaces for every country. So to say, you see in the top, you see the process that was reading the Inspire services, for example, from Germany, from Denmark, Spain, Hungary, Luxembourg, and so on. And just wrote that data into a PostGIS database. And we added another process to extract the information from geonames and join the geonames with alternative names and transform it to the PostGIS database, and then merge it into an enhanced Inspire with geonames dataset, and threaten it for the index schema to make it, to write it into the search engine index of Smart Finder. And all this was orchestrated by a main workspace, let's say. So this workspace fired up 5 other workspaces. So this is the main control workspace that you see. So it started, and it's on the. Do I have a mouse? It is started here, and first of all, we just truncated the background information of the Smart Finder core. There's a Smart Finder core, and there's let's say a staging Smart Finder database for the metadata information. Then we import the geonames data, and here in the middle you see 2 workspaces fired up with a FME server job submitter, one for the Inspire data and the other for the geonames data for every country. And then we just import the data into the Smart Finder core again. And as Commander Chris Hadfield just mentioned, the yellow box in the bottom, this is where failure comes in. This is the failure notifications that are sent out when one of the data of the workspaces just fails. Another thing to make this working good, we just made for every country own workspaces. So when one workspace fails, it doesn't mean that the whole workspace or for every country fails. So the data is available at every time. So this is like what a workspace looks like for a country. We have this is reading the data, and this is doing the mapping of the metadata to the DCAP AP metadata specification. For example, this is a workspace for Spain, reading the administrative units data of Inspire from the IGN in Spain. And for reading the Inspire data, we just built a custom transformer, which you see in the green box on the top, on the bottom. So what we did is we enabled a spatial search, so you can just look at the data in a spatial context. You don't have to use just a textual search, which can be confusing a bit when it comes to sometimes places have the same name, but they are in different countries, for example, and you can be confused about which data you are really looking for. But with a spatial search, you can just see what other spatial data is or other open data is around at your place. So this is what we did, or what we achieved with this project. And if you want to have a look at the workspaces, they are open like the data that is provided at European Data Portal. You can go to GitLab, European Data Portal, Gazetteer, Tree Master, FME. That's where you find all the workspaces that are behind this indexing machine that we built with FME server. And as Gerhard Schröder, the former German chancellor, said, let the data run, not the citizens. That means the users. This was, maybe is the conclusion of this presentation. So if you have any questions, just give it to me or give it to Dennis Willem, who's sitting in the front row. He did all the work at this project. He's the FME. I'm just technical sales, but he's an expert in doing consultancy with FME.
Excellent. So you do the work, he gets the speaker.
No, he
talk tomorrow, so.
Oh, that's good. So I see a hand go up there straight away from Ken. So
yeah, no, really interesting. The index schema, and what's the database behind there? What format does that go into?
I think it's PostGIS, isn't it, Dennis?
Well, basically the
Come on, our phone.
the service behind the search index is SmartFinder, which is based on a Lucene index and Solar. So basically, we provide a flattened JSON structure, which then can be indexed very well.
you put your data in JSON and it gets indexed. Fantastic. Any other questions? I guess I got one question, was that you get data from lots of different member states, I think you said. What format do you get that data in? Is it lots of different ones?
Yeah, a lot of different ones. So a lot of data is Inspire data. A lot of data is WMS.
Oh, really?
Inspire would mean it's WFS, WMS, or just Inspire GML. There's an Inspire GML format.
Okay.
Or it's KML, Shape, JSON, everything. So it's perfect for FME use as well.
I like that.
Yeah.
I was wondering if all of your data comes in as Shape, because that's just, everybody uses Shape. It's good to know that.
No.
It would if there wasn't this thing called Inspire, probably.
Well, yes. I think that's a fantastic.
Yeah, that's
project,
true.
though. I wish we had something like that in North America. Maybe I should wish for things like that.
We are prepared. We have an Inspire solution, but we can do one for America as well if you want.
So, one more question there.
With that main controller there, does it ever take one job and provide multiple outputs at once? For example, maybe one format but in different projections, or vice versa?
So the question is, do you ever have a process in the master that creates multiple outputs from one job?
No.
No, it's not processing the data. It's just processing the metadata of the data set. It's just building the index, mapping the metadata specifications, and it's just calculating the bounding box around the data, and just connecting this bounding box to points and to the data sets. So it's not really processing KML, Shape, or WFS or WMS or such things. Just one might believe that we used FME server to prepare all the data in that project, but it was just the metadata, I think.
Okay. So you sort of analyze the data set, find the extents, make it into a JSON, and then that becomes indexed.
Yeah, exactly.
And that makes it more discoverable and usable. Yeah.
Findable, yeah.
Fantastic. Any more questions? Well, I suspect that we're done for the moment. Thank you very much, Benjamin.
Thank you, Mark.
Thank you. That's great talk.